Alright, so that last video got cut off a little prematurely, but I'm going to pick up right where I left off, that we can determine that this series here will converge when x is equal to 3, and we can even go as far as to figure out what the series converges to using a formula for a geometric series. However, that's not the concern here, what it converges to. The question is a yes-no question. I've answered it, and I'm going to move on to the next one. So for part B, will the series converge if x is equal to 12? Well, we can do the same thing again. When x is equal to 12, the series that we have is the sum from n equals 1 to infinity. 10, we're substituting 12 in here, so 12 minus 2 is 10 to the nth in the numerator, 10 to the nth in the denominator. And this, again, this series is nothing more than 1 to the nth, which is just a bunch of 1s. And we know for a fact that this series will diverge, because what you're really doing is adding up a bunch of 1s an infinite number of times. So this will naturally diverge, so no. So now what we've seen here is an example of a series that is defined as a function. So you can almost treat this as like some function f of x. Right? And depending on the values, what we put in here for x, the series may converge or it may diverge. Now, we want to take this to another level where we're not just trying a bunch of values and seeing what happens. We want to see, we want to find all values for which the series will converge and all values for which the series will diverge. Okay? So let's work this out, and let's work this out in the general case. So let's just keep x in there and see what we have. So for part C, I'm going to start with the series, and I'm just going to rewrite it just a little bit as well as I did in the other cases. Instead of x minus 2 to the nth over 10 to the nth, I'm just going to rewrite this as x minus 2 over 10 to the nth. Okay? And again, this is just using properties of exponents. And we can see that this is a geometric series with a common ratio equal to x minus 2 over 10. Because we're just, for each term, we're just multiplying x minus 2 over 10 repeatedly by whatever number of times n is equal to at that point. Now we know for a fact that a geometric series will converge only when r, or the absolute value of r, is less than 1 and not equal to 0. Okay. So, or at least, well, maybe in this case as well, it may be convergent if x is equal to 0, but not necessarily if r is equal to 0. Okay, so we can just simply make a substitution here. X minus 2 over 10, the absolute value of that is less than or equal to 1. And we're going to solve for x. So this expression is really saying x minus, I can take away the absolute value by saying this is really just x minus 2 over 10 has to be between positive 1 and negative 1. Okay? So just think about absolute value as the distance from a number, and this is just saying that the distance of this expression from 0 has to be less than 1, which is the same thing as saying this. And now we solve for x, multiply both sides by 10, and then add 2 to both sides. So we get negative 8 is less than or equal to x, or sorry, is less than x, which is less than 12. Okay. And so this is what's meant by all values for which x will converge. It means that the original series that we had will converge if x is between negative 8 and positive 12. Now one more thing that I want to point out here is that we have to check the endpoint as well. So we must check the endpoints, because this may be that it could be equal to negative 12, and it could be equal to positive, it could be equal to negative 8, and it could be equal to positive 12. So let's check the endpoints. Okay, so when x is equal to 8, to negative 8, I'm sorry, the function that we have then is the sum from n equals 1 to infinity of negative 8 minus 2 is negative 10 to the nth over 10 to the nth, which is nothing more than the series of negative 1 to the nth. I forgot an nth here, to the nth. And so this series is going to alternate back and forth between negative 1 and positive 1. So it's going to be like negative 1 plus 1 minus 1 plus 1, so on, and this will diverge, okay, because the partial sums do not approach anything. So we don't need to put a, we do not need to put a equal sign under here. Okay. So then if we check when x equals 12, we already know that it will diverge because we did that in the previous part, that when x is equal to 12 it will not converge. So we also do not need to put an equal sign under here. But you will see other examples where maybe both of them deserve and need an equal sign, or maybe one of them does. Okay? So there we have it, just an example here of looking at a series as a function that isn't just all constant but may have an x in it. And depending on what values of x you have, the series may converge or diverge. Okay? So just to give you a preview or lead into the next video, this is talking about interval and radius of convergence. Well, the interval of convergence is right here, and I'll define it a little bit later. And the radius of convergence in this particular case is 10. Okay, so you could start at 2, go 10 in one direction, and go 10 in the other direction, and the series will still converge. Thank you for watching. Be sure to watch the next video, and have a wonderful day.